In this video, we're going to answer the question, why is there no tuple comprehension in Python? And since there is not, we're going to look at the alternative solution, the recommended solution of using tuples with generator expressions. So I thought a good place to get started would be this Stack Overflow question. Again, asking the question, why is there no tuple comprehension? And honestly, I love this answer. And it basically says, well, we didn't have any parentheses left to do it. They were already taken for generator expressions. So just to remind you, to do a list comprehension, we use the square brackets. You could even do a dictionary comprehension with the squiggly brackets. And then for a generator, we use the circle brackets. So these circular brackets that are used for tuples are also used for generator expressions, doing I for I, things like that. And that's why, since we don't have those parentheses, since we don't have generator expressions, what we do is we ultimately take the tuple built-in function and we wrap that around our generator, and we can do things like that. So actually, let me just create a generator for you, I for I in range 3, let's say. So we have a generator object. And next, we can wrap tuple around that, the tuple built-in function that is, and cast that generator object to a tuple. So this is basically the solution that is recommended. This is the way to turn a generator into a tuple, or any list comprehension style into a tuple. So if I come back here, and instead of doing a generator, we do a list comprehension. You can see that this is returning a list instead of a generator due to our choice of brackets. Now that we have our list comprehension, again, we could wrap tuple around that, and we've changed that to a tuple. And you can note the circular parentheses syntax for both the generator expression and the list comprehension. So that's the solution in a nutshell. And next, we'll break that down a little bit more. So to back things up for a second, how do you create a tuple? Well, you can use the circular brackets and just create it like that. Or you can use the tuple built-in function and create it like that. And do something like 1, 2, 3. But if you're going to use the tuple built-in function, you're going to have to cast one argument to it, such as an iterable. So that's one way that people get caught a little bit. Another thing you can do, I'm not sure 100% how this works in every situation, but you have a trailing comma there. And yeah, like cast a tuple in a tuple, kind of hard to explain. So if we did 1 with a comma, that should create a tuple. So if we did a equals 1 comma, if we check the type of a, we see we have a tuple. Kind of interesting, right? Or you could do b equals tuple and initiate an empty tuple, and we can check the type of that. Of course, that will be a tuple. And then what's the third one? That would be, of course, the most common one, which is where we just use the circular parentheses and create a tuple like that. And there we go. We can check our type, tuple. So basically 3 ways that you could have created a tuple. Next, let's look at generator expressions and see how that comes to be. So basically what you want to do is a for loop of some sort inside these brackets using the comprehension syntax. So you want to do I for I in, and then have any kind of iterable here. Obviously you don't use the word iterable. I just want to show you that you could pretty much do anything. So a string is an iterable, and we can say hey, or a tuple is an iterable, and we can throw a tuple in here and have a tuple inside our generator expression. Or of course we could do a list. And so all those are iterables and things that we can put inside a generator object. And like I mentioned before, we can take that list and cast it to a tuple, and that'll work just fine. So again, we could do the string and wrap the tuple built-in function around that, and we've created a tuple with strings inside of it. So these are all generator expressions, and then we're wrapping tuple around that. So the difference is when you create a tuple, you're not doing any sort of loop. You're just kind of casting that immutable object, and that creates a tuple. But if you do some sort of for loop in it, if the word for is in there, then you know that you're going to end up with a generator expression. So you're using those same parentheses, but the outcome is different based on what goes inside those parentheses. And it's probably worth noting one more time that tuples can go inside generator expressions. So let's just say we create a new tuple here, 1, 2, 3. And again, we can check type of A and ensure that that's a tuple. And let's create a generator expression with this tuple. So we can do I for I in A, and that's our generator object. And we could do whatever to check what this is. We can do a tuple, and that'll create a tuple. We could do a list, and basically just see that the values are in there. The values are inside this generator object, and it's a tuple that was iterated over to create that generator object. So we can turn generators into tuples, but we can also use tuples inside generators. So either one or both. Next, I want to show you something weird about what happens when you assign variables. So let's go back and take our generator expression. And I just want to make this a little bit more explicit. So that's our generator expression. And let's say we assign that to A. So what type is that going to be? Well, when we check, that is still going to be a generator type. But if we did something like put a comma here, when we check the type, we have a tuple because we have initiated a tuple. Going back to the beginning, that is a way that we can create a tuple. So even though there's still a generator happening here, it's ultimately being cast to a tuple. So that's why we end up with a tuple instead of a generator. So just something to keep an eye on. Also, look what happens when we just print out I, or A rather. So you see that this generator has actually been wrapped in a tuple, but it's almost like it hasn't executed yet. It's a little bit of a tricky thing. I don't think I'll be able to explain this perfectly, but just know that when you're assigning generator comprehensions to variables, there's some tricky things going on, especially in the context of a tuple. So taking that variable A that I showed you that looks kind of weird, it's like a tuple with a generator object inside it that hasn't been executed yet. Let me show you what that looks like in a for loop. So for I in A, for I in A, print I. So when we run that, it's printing out that generator object, which is kind of interesting. So it basically means that the iterable is the tuple itself, and there's only one value in that generator object, only one value in that tuple, which is the generator object. So that's what's getting printed out. But if instead we had done I for I in, let's say 1, 2, 3, we had our generator object, and actually let's assign that to B. So this is a generator object. This is going to be a little bit different than A, which was wrapped in a tuple, right? So that one was kind of a weird one that I wanted to show you guys. But with B, we're using a traditional generator object. It's not wrapped in a tuple. And when we go back to our for loop and do B, and we print that out, that's going to print out just fine because it's not wrapped in a tuple. So just something to be aware of, the type that you are iterating over. Another thing I want to show you guys is the size of these objects. So we know we have A, our tuple with a generator in it, and we have B, our generator. So here's what we're going to do. We're going to import sys, and we're going to do sys.get size of, and wrap that around A and see that it's 64, and around B and see that it's 128. So kind of an interesting thing that a tuple with a generator in it is actually smaller than a generator itself. Worth mentioning that a generator will pretty much always be 128. So even if I did something like C equals I for I in range 1000, and we have C here, and we can see that C is quite a big list. When we go to check the size of that, it's still going to be 128, just like B. So that's the idea of a generator, is it's not stored in memory. That's the value of it. It makes it much faster, and it's always going to be the same size regardless of how big it was. But instead, if we had taken our C, our list C, right, I guess I messed that one up. So let's say we come back and we create another one, we create C again, and then instead of a generator, how about we make D to be list C. Okay, so that's D. It's basically the same as C, except now it's a list instead of a generator. So again, C is a generator and D is a list. Well, how big is this list going to be? It is going to be a lot bigger. So C, our generator, was 128, and D, our list, with the exact same values, but a list instead of a generator, was much bigger. So generators are generally a very small memory imprint, but it's just kind of interesting that our generator inside a tuple ended up being smaller than the generator itself. So I don't really know what you can glean from this, but just something I wanted to show you guys, something I thought was interesting. Now, lastly, I want to show you guys a cool trick you can do to cast a generator to a tuple. So let's say we had I for I in range 100, right? So this is our generator object. And typically, what I've recommended since the beginning of the video is to wrap a tuple around that, the tuple built-in function that is, and that'll change that to a tuple. But there's actually another way you could do this, and that's by putting a comma in the end and putting a star up front. And when we run this, we've created the exact same tuple, but just with a different syntax. So I'll run that one more time just to show you guys. Again, a star at the front and a comma at the end. And when we run that, we get our tuple. And the star is very important because without it, we're going to get a tuple with a generator inside it. So the star is really doing all the magic on this one. Apparently, it's very slow. It's the equivalent of if you did this. So I've read that it's the equivalent of if you did a tuple and then wrapped a list and then wrapped a tuple around it. So I have heard that tuple list is the same as this star syntax. So something to keep in mind, the star syntax and list tuple are said to be the exact same order of operations, not even syntactic sugar or something. They're said to be the exact same order of operations. So just a trick I wanted to show you. It's supposed to be slow, but since we're talking about tuples and generator comprehensions, thought you guys might think that's cool. So in summary, there is no tuple comprehension. I guess there technically could have been, but ultimately there is not. And what you want to do is just use the tuple built-in function and wrap that around your generator, your list comprehension, whatever it is. So the tuple built-in function is your friend, and that's how you can create tuples out of comprehensions. So hope you enjoyed this video. Thanks for watching.